This PetroSkills PetroAcademy skill module covers rod, PCP, jet pumps, and plunger lift at the core competency level. Proper artificial lift selection, design, implementation, and operation for producing well completions are critical factors in achieving both optimum production rate control over time as well as maximizing ultimate recovery over the life of a well's completion history. Rod pumps dominate the oil field with regard to the total number of units operating worldwide for very specific reasons. Once properly engineered and installed, and with proper well surveillance, rod pumps have proven their durability and competitive and technical superiority over time for an appropriate set of well conditions. The ability to design and operate commercially attractive artificially lifted well completions for conditions such as low-energy reservoirs characterized by low productivity, low gas-liquid ratio, high viscosity fluid production, significant water cut, some sand production, some paraffin wax present, with corrosive conditions mitigated by metallurgical and chemical treatment programs. All of these conditions result in rod pumps commonly being selected as the artificial lift selection of choice, and the above conditions described have a much broader scope of why rod pumps may be the best choice of artificial lift completion for all or just certain wells in a field. Similarly, progressing cavity pump PCP artificial lift has a set of conditions which favor the use of why PCP pumps are chosen. For example, PCP pumps do an excellent job of handling high viscosity heavy crude with moderate sand production from wells of significant depth, such as 6,000 feet, 1,828.1 meters. Canadian heavy oil production operators rely upon PCP technology in high-temperature thermal recovery operations that PCP pump systems support. Jet pump completions are a unique artificial lift application. Jet pumps are often considered to be the most versatile artificial lift type. This fact alone would by itself seem to indicate that prolific use of jet pumps would be found throughout the oil field. Understanding why such is not the case is due to the corresponding jet pump feature that they are by far also the costliest type of artificial lift application, and they are often challenging to operate. The downhole component of the jet pump system creates a Bernoulli effect that blends what is referred to as the jet pump power fluid pumped downhole at high pressure to combine with produced fluids and flowed to the surface. What follows at the surface is a separation process to separate produced oil and water from the power fluid. Jet pump technology and its attributes, high pressure operation, continuous fluids separation, power fluid selection, etc., also present an environmental and safety concern. The most common answer why plunger lift artificial lift technology is applied in the field is that once properly designed and installed for wells meeting strict candidate selection scrutiny, it permits the recovery of gas reservoir remaining reserves down to reservoir depletion pressure, and properly operating plunger lift systems operate at very low cost levels. In summary, why specific artificial lift technologies are applied and others excluded for wells across a wide range of conditions is due simply to the fact that well and reservoir characteristics and conditions dictate what technology works well and what does not perform well. This fact does make the selection process to arrive at the most appropriate artificial lift type a matter of thoroughly understanding the reservoir model, the geological model, and artificial lift attributes that address the unique characteristics of all oil and gas assets requiring artificial lift assist.